Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I'm going to take you through the final steps in post-processing and reporting on an aquaculture grid mooring system and analysis. So where last we left off, we had run our multiple cases in waves, and what we'll do is we'll just take a quick look at the results. Results.pdso. Now, we started these analyses with a steady load of the fish farm system in a current profile, and then we applied a maximum design wave approach by having an individual area wave ramping up one period and then the full wave period through the whole farm. It's always a good idea to visually check, spot check a couple cases and just take a look at them to see if that makes sense. So here's our farm. Let's go to engineering view and we'll plot the color tension here. So there's the initial tension. This is like around 18 kilonewtons in sort of this orange color here. That's from the steady current. And what we'll see is we can play it back, but you can just grab the slider and then we start to see some dynamic loads from the area wave in the system. Now it's kind of hard to see that. Remember that this is a case with 0.25 meters per significant wave height. Just double check that. This is case 0, case 1, sorry. Yeah, let's change this to NS94015. Yeah, 0.25 significant wave height. So not a huge wave height. But you can see, there you can see the motion of the system in these conditions. So, and again, we can do plotting. Actually, if we just pick any line here, we can go plot tensions. If you recall from last time, this 19 and 18 were the most loaded, just from visually looking at them. And we'll pick those two to make our plot. And remember, N1 is at the grid. So yeah, you can see there's the pre-tension values from current, and then there's some, from the ramping up wave, there's a little bit of dynamics, and then we're seeing maximums, around here. Some of these waves the wavelengths are comparable to the length of the farm. So depending on where they are, and you'll see the peak appear at different times in the simulation. But in any case, here's the maximum around 22 kilonewtons. And now the question is there a way to systematically and easily post-process all of this data that we've got for the 8 cases and then find the worst case loads? And that is what we're going to use the fish farm report tool for. So the ProteusDS fish farm report tool is pretty straightforward to use. What we want to do is browse by folder. And when we do browse by folder, it's going to pick out automatically all of the cases in there and then show us the worst case loading scenario. And we'll leave all these categories here for bridle lines, buoy lines, mooring lines, and so on. It keeps it pretty organized. You can select units that you're comfortable with in here, but you can actually also change that in the Excel file that's generated as well. So we'll hit generate. It's going to take a little while here to read through all the data. And once it's done, we will open the Excel file accordingly. So just as a reminder, it's going through all subfolders and picking out the maximums from the entire set of cases that we've run. So yes, we want to open the results. Now, as I mentioned, you can actually click on the units here and change them after the fact if you want to. You don't have to, but it makes it very flexible to work with. And now on the summary page, it's giving you where you can see the worst case loading in some of these lines. And if you look at the required safety factor, you can pick out a few different standards that are available. If you look at NS9415 ULS, what that's going to do is based on the maximum loads, it's going to help just verify what the minimum required component braking strength is. So you can see that the lines that we have in the grid line are actually quite large. got a lot of significant safety factor here, so we're doing just fine in terms of the components there. Of course, you can go through and look at all of the loads from all of the cases in the mooring line spreadsheet here. So again, it's looking at all the mooring lines and giving you a summary of all the loads that are in there. So it's a great way to aggregate the effects and see what the worst case scenario is as well. And that's what I wanted to show you in terms of the maximum loads in the whole system. So maybe just a spot check here. We see case 5 is where we're seeing a lot of the maximum loads there. If you do a bit of a reality check and go back to Case Explorer here, you can see case 5 is a case where we've got the largest wave height. Case 6 as well, but and this just looks like a particularly a larger worst case scenario for the combination of currents and waves. So that makes a lot of sense in seeing those maximum loads there. All right, well, thanks for watching.